Hi, it's Friday, September 26th. We're continuing to track two systems in the Atlantic. One is 94L, a disturbance moving through the Greater Antilles and into the Bahamas region. And the other is now Hurricane Humberto, strengthening and moving slowly to the west-northwest into the southwestern Atlantic. You'll have to bear with me here. There's a lot to discuss as we've been going over for the last couple of days. The interaction between these two systems is adding some complexity and some added uncertainty that's a little higher than average in the forecast for the next few days. But there are likely to be impacts from one or both of these systems in the southwestern Atlantic region, possibly including the United States. So there's a lot to get to here. We're going to start with Hurricane Humberto. Here's the infrared satellite picture. You'll see an eye now today. This is a distinct change from yesterday when this was still a tropical storm, struggling with vertical wind shear tilting the vortex eastward with height. We talked yesterday about how the shear would likely slow the intensification rate for the next day or day and a half before relaxing. That turns out to have been a little bit quicker of a process than models expected. So we have had the circulation align and we have an eye clearing out. So this is now a hurricane with max winds of about 90 miles per hour. Perhaps will be a bit stronger on the next update, likely to be a category 2 hurricane or so very soon. If we look at the vertical sounding from the ECMWF model, we'll see what happened here. The analyzed shear for the time of this video is now just 6 knots out of the southeast. If you look at this value from just a couple of runs ago yesterday, you can see the forecast from the model was for stronger, moderate westerly shear, and this has now relaxed more quickly than models anticipated. So with the shear already decaying, the storm has vertically aligned and intensified quite a bit. This is the water vapor satellite loop showing the westerlies associated with the upper level trough to the northwest of the storm. And the outflow from the storm has been fighting that shear pretty effectively over the last 24 hours. You see a well-defined poleward outflow channel there, and it looks like the shear is just not enough to disrupt the inner core at this point. So this is on its way and will continue intensifying as it begins to move west-northwest and then northwestward to the south of Bermuda. And from this point forward, shear is likely to stay in the light range, light to moderate, and we're likely to see favorable conditions for this to remain a strong hurricane and likely a major hurricane at some point. That would be a category 3 or stronger storm over the next 3 to 4 days. And the broad anticipation is for this to be a strong storm that gradually curves towards the north and the northeast out over the open Atlantic. This is the current set of track models showing Humberto making that curve, and pretty good agreement here, as you can see amongst all of the models. A little bit of uncertainty as it's moving west of Bermuda, as you might expect, especially as it interacts with the other storm to the west, which we're going to talk about in a second. But you can see Bermuda here, still a nice comfortable margin where this is expected to be west of the island, which is good news, but that doesn't mean there can't be some shifts. This is a 4 to 5 day forecast, and the island will need to monitor for any shifts in the track forecast closer to the island. Even if it takes this track verbatim, could still be peripheral effects that impact the island due to the outer wind field and high surf due to the waves radiating outward from what is likely to be a strong hurricane at the time that it moves west of the island. This is the NHC official forecast showing exactly that. The M symbol here means major hurricane, so category 3 or stronger, and it's expected to be strong throughout this journey, only weakening at the end when it begins to turn northeastward and encounter the mid-latitude jet stream. And as it moves west of Bermuda on this forecast, again, we'll be watching for peripheral impacts and any shifts in the forecast over the next few days. Okay, with that, we're going to shift over to the other system. This is Invest 94L, still a disturbance as it moves across Hispaniola, the Turks and Caicos, southeastern Bahamas, and eastern Cuba today. This continues to be disorganized. This is the zoomed in visible loop from this morning, and it's going to be difficult to identify any kind of circulation because there really isn't one. We're still dealing with a trough axis or a wave at this point. If we start to collect visual observations of the low-level clouds, you'll see that there are northeasterlies over this part of Cuba here. You're going to see easterlies up in the central Bahamas. It's difficult to see what's going on beneath the murky clouds over here, but likely southeasterly flow. You'll see slight southwesterlies at the surface in the gap between Haiti and Cuba. And then what you'll notice over eastern Cuba itself is that there are a little bit of southerlies right here. And then there's this area of light easterlies and then nearly calm flow right in here. And so we're starting to narrow down where the wave axis is, or the nexus of what is likely to be a weak circulation. It's somewhere in here, straddling eastern Cuba and the area offshore of eastern Cuba. This is where the surface wave axis is, the maximum piece of vorticity associated with this system, and it's very weak and diffuse. Now, the mid-level trough axis is still somewhere over here, kind of centered off to the east, because there is still some vertical shear present out of the west, and the system remains disjointed and tilted with height. So the mid-level vorticity maximum is somewhere over in this area, whereas the surface vorticity maximum is here. And this disjointedness is a sign of disorganization and a sign that we likely won't have a tropical storm anytime within the next 24 hours, because we're starting from nearly nothing here. There's not a lot of structure to work with. However, development is nonetheless expected, because as you can see, there is deep convection beginning to sputter throughout this wave pocket. And given that it's going to move into an area of open water here near the Bahamas over the next couple of days as it moves northwestward, vertical shear is expected to lessen a little bit, although not totally disappear. And there's some deep moisture facilitating this thunderstorm activity. So given enough time, we are expecting amplification of a new circulation and the formation of a bona fide tropical cyclone as the system moves toward the northwest. Here's the water vapor satellite loop showing the upper level trough to the north, rather weak at this point, but you can see some of the westerlies here. So that's been some of the shear that has led to the tilt in the system so far. It's now going to be handed off between two different troughs. This trough is weakening and disintegrating as Humberto comes on the scene from the right-hand side of your screen. But we have another weak trough over western Cuba and South Florida here that's imparting some southerly flow over Cuba, and that's going to be the primary flow that begins influencing 94L. And so the shear is going to essentially switch directions from out of the west to more out of the south, and likely a little bit lighter in magnitude. This is a more favorable environment for the system, but the shear will not go away either. And when it starts moving towards the north, that southerly shear will start to matter a whole lot. And we'll talk about that closer to the end of the video when we talk about the intensity forecast for 94. This is the GFS, and one of the big things about this system is the track. 94L has an uncertain track, and a lot of it is tied precisely to where it first forms and anchors down on a tight, well-defined circulation center. And we still have disagreement in modeling about where that's going to happen. I just showed you where the system is on satellite imagery, and it's somewhere near eastern Cuba or just offshore. This is the GFS forecast for just a few hours from now. This is 8 p.m. Eastern time tonight, and you can see where it has the surface center, and it's doing a good job at showing where this is based on where the system is currently analyzed. The wind barbs here are mid-level wind barbs, and the coloring is mid-level moisture, and you'll see the mid-level center is off to the southeast due to that tilt that we talked about due to the vertical shear. Now you see that it has this located in a decent spot and is likely to be realistic, but if I go forward just a little bit, you see how it immediately jumps into the northern part of the southeastern Bahamas. Instead of remaining anchored down near Cuba, there's this thunderstorm complex that develops in the model and immediately generates new vorticity on the northeastern side beneath the mid-level wave axis, and that becomes the anchor for the new storm on this model. This matters a whole lot because it gets into the northern Bahamas in a hurry relative to an alternative future where the system remains down near Cuba for a longer time and then drifts north, developing more slowly and from a more southerly position. This has been consistent in the GFS for some time, where it's trying to jump the storm to the north. This matters a lot because, as we went over yesterday, this puts it on the fast track towards the north before Humberto gets close enough to influence the storm and try to pull it offshore. Here's the 500 millibar steering flow in the mid-levels from the GFS, valid for Saturday evening and early Sunday morning. There's 94L, or what would be developing into Tropical Storm Imelda at this point. Humberto's just coming onto your screen in the lower right corner, and we have this upper level trough over the Appalachians. Now, because the GFS develops this pretty far to the north right away, this trough kind of captures the storm and pulls it in towards the coast almost immediately. So you see the storm race off towards the north-northwest. The The hurricane is getting close to it, but it's too late to prevent a landfall. The storm ends up racing into South Carolina on this model run, merging with the remnants of the mid-level trough over southern Appalachia beneath of this ridge that is moving over the Great Lakes region. So that's one model's opinion. Let's look at another. Here's the ECMWF or European model. This is for Saturday evening. Here's developing Imelda in the central Bahamas. It's not quite as fast at getting to the north as the GFS, but as we'll see here, it is fast enough such that it does essentially outrun Humberto. Again, what's happening here is these two storms are having a steering influence on each other, where one storm's circulation is trying to pull Imelda back towards the south and east, and Imelda is also trying to pull Humberto towards the north. They're trying to orbit each other, and this influence will grow stronger with time as the storms get closer and closer together. But on the European model, Imelda essentially outruns Humberto and gets into the southeastern US prior to the hurricane's influence becoming strong enough to keep it from moving onshore. So on both the GFS and ECMWF, we continue to see landfall scenarios from these two models. Now, if I go back to the beginning, you'll see just how sensitive this forecast is to the very short term. We're talking about today, tonight, and tomorrow could determine the entire future of Imelda, because if you look at the location of the developing storm on the European model and then compare it to some of the other models that show a different scenario, for example, the AIFS version of the European model, you'll see how different the location is, where the low stays near Cuba for a longer time on this particular model, and not just AIFS, but also the German and Canadian global models as well, a little closer to Cuba. And this example is so stark that it's worth showing. The uncertainty about where this consolidates over just the next 24 to 36 hours could determine the entirety of the rest of the track for this storm. If you follow this particular model forward, it is slower to get out of the Bahamas. So guess what? Humberto is able to get close enough to influence Imelda prior to making it into the southeastern US. The result on this model run is that the pull of Humberto on Imelda is enough to counter the influence of the trough over the Appalachians, and the two end up orbiting each other in a way that keeps both offshore, and Imelda actually starts moving off towards the northeast as this blocking ridge moves on towards the north, and Humberto moves out into the open Atlantic northeast of Bermuda. Both of these scenarios, in my view, remain on the table. We have unanswered questions about where the storm will consolidate over the next day or day and a half, and models on different sides of that question end up showing different scenarios for landfall or lack of a landfall for future Imelda. And this remains a fundamental split in the guidance that remains an unanswered question today. Even in some models where landfall is depicted pretty consistently, like the GFS, there is still uncertainty. In the ensemble system for the GFS, the GEFs, we do have spread in the members where there is a grouping that makes landfall. The faster members make landfall, but the slower grouping you'll see actually hangs out near or offshore and never quite makes it to the coastline. So even within the GFS, which has been a consistent landfall model, we have ensemble members that depict a lack of a landfall. That doesn't mean there wouldn't be impacts from a storm that was this close without making it ashore, but it's a recognition that there remains uncertainty here, and a landfall isn't yet a guarantee. You can see this also again in the Google DeepMind ensemble, which I've been showing you for the last couple of days. You will see a trend from yesterday. Yesterday, the landfall group 494L/Imelda was smaller in number than it is today. You'll notice that there's still the two branches here. Here's the landfall branch and the out to sea branch, but the landfall branch is more numerous now, probably about 60% of the members, whereas yesterday it was a much smaller fraction, certainly a minority. So relative to yesterday, we have seen a shift in this particular ensemble towards higher landfall risk than yesterday, but there remains a split here, and both scenarios, as I said, likely remain on the table. And why is that uncertainty so high? Well, mostly because we don't have a storm yet. It needs to form, and we need to see where it is, because where it is determines how quickly it gains latitude relative to this storm. You can see on the ensemble mean here, when it's in the northern Bahamas, it's at roughly the same latitude as Humberto, and this is a really important metric. If Imelda is north of Humberto the whole time, we likely get a landfall in the southeastern US, but if Humberto at any point is north of Imelda, we likely do not get a landfall. That seems to be an important metric in modeling right now. We're going to continue sampling data. We've got the reconnaissance hurricane hunters out of NOAA dropping dropsondes and taking measurements in the southeastern Bahamas, north of Hispaniola and eastern Cuba, trying to get as much data into these computer models as possible to give us the best estimate of the future and what the different scenarios are. Although uncertainty is much higher than we want it to be right now, we're likely to know a lot more once we actually see a circulation develop, as soon as we see where that is and once it is well defined. I think confidence from the forecasts will increase markedly and we'll hopefully have clarity on the scenario that's coming. And look, we've already seen models making mistakes just in the last 24 hours. In the last video, if you remember the GFS and what I showed you, it thought that today there would already be a new circulation developing on top of the Turks and Caicos. We do not see that in observations and satellite imagery today. So models are already getting things wrong in the short term. We need to see that stabilize and see a well-defined system develop before we actually know the future. Now, I do want to spend some time here talking about potential impacts, because at this point, if we're about 4 days from a potential landfall in the southeastern US, I think folks need to be getting prepared and have a plan ready for action in case this scenario of a landfall in the southeastern US actually does occur. One of the big things I want to point out here is that this could be a high rainfall event, regardless of how strong and what the structure of future Imelda is. If it's moving into the southeastern US and then Humberto is moving towards the east, there's a chance that it slows down and just sits over the southeastern US for some time and drops a lot of rainfall. This is the GFS showing an example of what the next 6 days of rainfall can be. You can see the track on the model. This is just one model, one particular scenario, but you can see all the heavy rain that falls predominantly in the Carolinas on this model run. Here's the opinion of the ECMWF, which also has a landfall in South Carolina. You can see the widespread area of 6 to 10 inches falling in southern Appalachia and all the way to the coastline throughout this part of the US and up into the mid-Atlantic as well. These are just two possible versions of the future. This is not an official rainfall or flooding forecast, but I think you're going to see your local National Weather Service office start to talk about this more over the next couple of days, because unfortunately we have a situation where as the storm moves ashore, you see that a lot of these ensemble members just sit here for a couple of days because we have the hurricane to the east imparting a steering influence that slows the storm down. Even after landfall, it may just sit there for a time, could even come back out over water in some scenarios, and there's this blocking ridge up to the north kind of containing the storm or its remnants in southern Appalachia for several days potentially on some of these outcomes. That could result in a lot of rain, and there is going to be a lot of moisture being pumped up into the southeastern US associated with this system. Now, besides flooding, of course, there's also going to be the concern of, will this get strong over water, and will there be a storm surge at the coast, and will there be high wind threats? Well, let's take a look here at the upper level conditions on the GFS as an example. This is the 200 millibar wind flow. This is Imelda developing in the northern Bahamas on early Sunday. Again, this is one of the faster models, so you'll see this getting ashore rather quickly on this model run. But you'll see the big feature here is this upper level trough over the southeastern Gulf and Florida, imparting this southerly flow or south-southwesterly flow over the storm. So there is going to be some shear here. You'll also see this subtropical jet with convergence, speed convergence. This air is decelerating as it pours down into the Gulf. That's causing subsidence in the large scale and therefore lots of drying here. This is dry and subsident air. And if the storm is developing especially quickly, that circulation will likely entrain some of this dry air. And you do in fact see that on the model. If we look at the mid-level moisture plot, again, very dry here, as I just said. And then here's the storm. You'll notice this dryness encroach on the southern half of the storm because there is shear out of this direction, forcing the dry air in. So you'll see that there's an asymmetry to the storm structure. There's the center. The northern half is where all the green moisture and rainfall is. The southern half is dry and mostly cloudless on this model run. Now, this is going to be a little delicate because there's not a guarantee that this will sufficiently disrupt the storm in a way that prevents intensification. Rather, we're likely to see moderate shear and some uncertainty about how effectively the storm holds up against that shear. On the GFS, you'll see that there's asymmetry for most of this journey, but right before landfall, you see some symmetrization of the moisture field occur. And this is because if we look at the upper level flow, instead of coming out of the south-southwest like it is at the beginning, the storm is strong enough that it kind of helps this trough reorient in a negatively tilted fashion, and the upper level flow becomes more southeasterly more than southwesterly. This lowers the total value of the wind shear because the surface flow is more aligned with the southeasterly upper level flow. And in addition to that, you see a lot of upper level diffluence here. There's a bit of a jet streak on the eastern side of the trough, lots of upper level divergence on the northern side of the storm. This ultimately helps the storm fight off the moderate shear and symmetrize the convection in a way that leads to intensification right as the storm is coming inland. And so on this version of the future, Imelda is a hurricane strength system at landfall, and you do have the worries about high wind and storm surge to go along with all of the rainfall and potential inland flooding if this were to come to pass this way. Now, there is an alternative version of this future where the storm is less effective in fighting off the moderate shear and dry air. This is represented fairly well by the European model, where you get a similar situation where the storm is initially asymmetric north of the Bahamas. The difference in this case is it is not able to symmetrize coming up to the coast. So you see this asymmetry persist where you have moisture all on the north side, dry air on the south. This shear has continued to lead to a one-sided, lopsided storm. And so by the time this makes it to the coastline, it is not a hurricane strength system. Rather, it is a tropical storm. That doesn't mean that wind and storm surge threats would be zero in this situation, but it would be less than the threats associated with the other models that show stronger storms here. So there's a range of outcomes. Right now, it seems like at least a medium strength tropical storm would be most likely here at the least, with risk of a hurricane developing if the storm is able to symmetrize. Some of this will depend on, again, exactly where the storm forms and how quickly it comes northward, because the alignment with this upper level trough and the associated jet streak here will matter. And so how quickly the storm is moving northward will affect this a little bit. So there's a range of possible outcomes in terms of how strong this gets, likely to be weaker than Humberto, which will be a bona fide major hurricane, but this still has some risk to become a hurricane strength system that brings the full gamut of threats to the southeastern US if the landfall scenario comes to pass. And like we talked about, the risk of that has increased a little bit today based on current modeling. So this is something folks need to be prepared for. There could be a legitimate hurricane threat in this part of the country, along with a lot of rainfall over a wide area. So we're going to continue monitoring both these systems, of course. I'll have more updates on my social media. You can check tropicaltidbits.com for the links to those. And we'll continue to track this. National Weather Service offices in your local area will be talking about this over the next couple of days. Folks in the Bahamas and Turks and Caicos likely to get heavy rains and potentially some higher winds, especially in the northern Bahamas if a storm is developing in this region. And we're likely to see that occur at some point over the next couple of days. Humberto, again, expected to track west of Bermuda at this time, but the island will, of course, continue to watch, and there could be peripheral impacts. And we could see impacts to the coastline all up and down the eastern seaboard, if not from winds and rain, then from ocean swells and potential for high surf and rip currents. So everyone along the eastern US, keep a close eye on these systems. That's it for now. Thanks for watching.